What's up, people? Welcome to today's session. How are you guys doing? I hope every one of you guys are doing good, taking care of yourselves. And a very warm welcome to Vedantu's 9th and 10th English channel. So yes, people, finally for all the ICSE students out there, I know you guys have been complaining a lot that there's not been a lot of ICSE sessions going on. First of all, I'd like to apologize for that, but we're here to, level the ground right now for ICSE students as well. So we are going to be starting off with one-shot series for light chapter, that is refraction of light at plane surfaces. So I hope you guys are ready for this one because it's going to be a long ride where we're going to be completing the entire chapter in the next couple of hours. So this is the first session. We have another set of sessions that is going to that will be coming out pretty soon. So make sure you subscribe to the channel as well. All right. So that's it, people. Let me introduce myself. My name is Anoop. I am a master teacher of physics here at Vedantu. And a very warm welcome to all of you guys out there. And I hope every one of you guys are doing spectacularly well, right? So let's get started, right? Let's not waste any more time. So people, in this particular one-shot series, what are we going to be doing about, or what are we going to talk about is basically, we'll understand what is refraction first. We'll start from the very basics and go all the way to the top. We'll make sure that everything is covered in this one-shot series. So we'll understand what is refraction of light first. We'll understand what are the laws of refraction, what is a refractive index, both absolute and relative refractive index. What are the factors affecting refraction and principle of reversibility? And these are the things that we'll be doing in today's session. And apart from that, we'll also be doing refraction through a prism, what is that angle of deviation, real and apparent depth, and finally, we'll also understand what is critical angle, total internal reflection, and how does total internal reflection happen in prisms. So with that said, people, let's get into today's session. Let's understand what is refraction. Now, in simple words, guys, refraction is nothing but the bending of ray of light. When light is entering from one medium to another, for example, let's say I have a glass of water. Yes, I do have a glass of water. So imagine light is entering from air to water. So light is entering from air into water. So if I were to put a pen inside this jug, inside this mug, all of a sudden, this mug, the pen, looks like it's a little bent. If you look very carefully, you can see that it looks like it's a little bent. This bending of light, when light is traveling from one medium to another, that is what is called as refraction. So that is what is, in simple words, that is what is refraction. So this is what it would look like, the bending of ray of light. So this is how the light was supposed to go, but then because of the fact that light is entering from one medium to another, from air to glass or from air to water, this is what is named as refraction. So if I have a rectangular glass slab, simple rectangular glass slab, in that my refracted ray would look like this. So this is my incident ray right here. It's because of refraction, it takes a different path. It bends from its original path. So initially, if I were to draw a normal, it bends towards the normal. The refracted ray is actually towards the normal. And then as the light leaves the glass and enters back into air, it again goes away from the normal. So this ray of light is called as the emergent ray, this is called as a refracted ray, and this here is called as an incident ray. Now the thing about a glass slab is that in a rectangular glass slab, the emergent ray that comes out is parallel to the incident ray. You see this is the original path of light. Light was supposed to go this way, but because glass got in its way, what happened was that light took a different path. I don't know what happened over there, but yes, what happens is that the emergent ray that is there is actually parallel to the incident ray. This is what is called as lateral shift. So in a rectangular glass slab, what you see is that it looks like someone was so angry that they picked up the light ray, took it and just kept it to the side. So that is what it actually looks like. So that's why it's called as lateral shift, because the emergent ray is actually parallel to the incident ray. So one of the things that you need to remember, one of the most basic stuff that you need to remember is that light, when it's traveling from rare to a dense medium, that is, a rare medium is one where the speed of light is very high. For example, in air, the speed of light is around 2.9 into 10 to the power of 8 meter per second. On the other hand, if I talk about glass or any other medium, for example, if I talk about glass, the speed of light is around 1.97 into 10 to the power of 8 meter per second. So there's a clear difference, right? So speed of light in air is much more greater than that of glass. So if the speed of light is more in a certain medium, that would be called as a rare medium, and the medium in which the speed of light is a little less, that would be called as a dense medium or a denser medium. And when light is entering from a rare medium to a dense medium, like in this case, how it's happening is that light is entering from air into glass. So from a rare medium to a dense medium, in that case, light would bend towards the normal. On the other hand, when light is traveling from dense to rare medium, the other way around, when it's traveling from dense to rare medium, in that case, light is going to bend away from the normal. Simple, right? That's what I showed over here. So here, you see this, it's bending towards the normal. Like in this case, this is the light and this is the refracted ray. It's bending towards the normal. And here you see this is traveling away from the normal. Right, guys? And yeah, what is the reason for this? All of that is because of the fact that light has different speeds in different mediums. So when the speed of light is more in a certain medium, when it's entering from a dense to rare medium, the speed of light is suddenly increasing, right? So basically what happens is that it would change the path such a way that it is traveling away from the normal. Simple, all right? Now, again, I could get into the technicalities of it. It would take a little longer to explain. So let me just say it if you want to. So here's the thing, guys. Light always wants to take the same amount of time. Now, what do I mean by that? Light is very punctual. For example, we know that speed is equal to distance by time. We know this. So when light is entering from glass to air, the speed of light is suddenly changing. It was slow before, and now already it is becoming very fast. Like suddenly it's becoming very fast. So in that case, what is happening is the speed is increasing. But like I told you, time taken by light has to be kept constant. Light does not want to be early, neither does it want to be late. It has to be exactly on the same, it has to take same amount of time. So what should it change? It should change the distance. So it will travel a longer distance when light is entering from a rare to dense to rare medium, from a dense to a rare medium, because the speed of light is increasing. So in order to keep the time taken constant, it would basically increase the distance. Again, I hope you guys have understood this. I can give you a lot of examples, but that again, one of the most basic concepts. I'm guessing that you guys already remember this, and you guys have already studied this, and you understand it already. So I'm going to go ahead, assuming that it is done, because guys, again, it's a one-shot series, so we have a lot to cover. Moving on. Okay, so here's the thing: one more thing is that when light is incidenting normally, that is, if it is exactly falling at the normal, in line with the normal, so angle of incidence is 0 in this case. If that is the case, then the light ray would pass through undeviated. It will pass undeviated without any deviations whatsoever. Right, guys? Now, apart from that, we have a lot of other examples that we can talk about when you talk about refraction. One of that is being a coin that is put in a glass of water. So when you put the coin in that water, there are few rays of light that is coming and falling into your eyes. But when you put the water inside, what happens is that the coin appears like it's a little raised. So what happens is when your eyes are trying to trace back the source of this light, the coin appears like it's a little bit more higher than the actual position. Again, so what's happening is that because of refraction, there is an image being formed, and that is the image that you're seeing over here, which appears or makes it appears as though the coin is a little raised. Another example for the same can be, you can just, every one of you guys have buckets in your washroom, right? Fill up the bucket with some water and just look at the base of the bucket, all right? Just see it from a side, from a different angle. You see that the bottom part, the base of the bucket, looks like it is a little raised up. It looks as though the bucket is actually a little bit shorter than its actual height. Again, it is all because of refraction. But one thing, guys, light is not a lawless man. Light is not like John Wick. It's not like it'll do whatever it wants. Light is more like Sheldon Cooper, from Big Bang Theory. I don't know if you guys get that reference. In other words, light follows laws. There are two important laws that a refracted light would always follow. The first law of refraction is that the incident ray, the refracted ray, and the normal will all lie on the same plane. So if I were to introduce a 2D figure like a piece of paper, or A4 size sheet or something, all of those, the refractory, the incident ray, and the normal, should lie on the paper itself. It cannot lie outside the plane. A refracted ray cannot lie, it cannot lie outside the plane or behind the plane. It has to lie on the plane itself. That's the first law. The second law is also called as a Snell's law. So what is the second law? See guys, if you remember in your reflection, you'd have probably studied that angle of incidence is equal to angle of reflection. This is the second law of reflection, right? You'd have probably studied this. But if you talk about refraction, guys, it's a little different. The relationship between angle of incidence and angle of refraction is that the sine of angle of incidence to the sine of angle of refraction is equal to the speed of light in the first medium divided by the speed of light in the second medium. Now this is the relationship between angle of incidence and angle of refraction. Unlike reflection, this is what the law states. So if I have to define it in terms of words, this is what I would say. The ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of medium. Why do I say it's constant? Because guys, for example, if I talk about air and glass, speed of light in air is always going to be 2.9 into 10 to the power of 8. Speed of light in glass is going to be 1.97 into 10 to the power of 8. Now this value is not going to change. This value is not going to change. So if I find the ratio of this, that is, if I take this one as V1 and if I take this as V2, this ratio, whatever I take, V1 by V2, this will always be constant. This ratio that I get will always be constant. So you can say that for a given pair of medium, since I already know the speed of light in those mediums, we can say that for that pair of medium, the ratio of sine of angle of incidence to the sine of angle of refraction is going to be a constant. And that is your second law of refraction, also known as your Snell's law. Moving on, guys, we also studied about refractive index in this chapter. That is, what exactly is refractive index and what is absolute and relative refractive index. Let's start with the refractive index. Refractive index of a medium tells you by how much a ray of light is going to bend in that medium. It basically tells you by how much a ray of light is going to bend in that particular medium. Now, there are two types of refractive indices. One is absolute refractive index and the other one is relative refractive index. Absolute refractive index is nothing but, let's say a ray of light is entering from vacuum. That is, let's say you're an astronaut for a second. You're in the International Space Station. Now, light coming from the sun is coming from vacuum and is traveling in space, which is vacuum, and it's entering into glass, right? So light is entering from vacuum into glass. So there's some refraction happening. This is what is called as absolute refractive index. When you're comparing the speed of light in vacuum to a certain medium, that is what is called as absolute refractive index. Basically, it basically gives you an idea of what or by how much a ray of light is going to bend if light was entering from vacuum into that particular medium. So that is what is called as absolute refractive index. So in simple words, the formula is what? N is the absolute refractive index, which is equal to speed of light in vacuum, which is represented by the letter C, divided by the speed of light in that medium. Now, speed of light in vacuum is always constant. So C is equal to 3 into 10 to the power of 8 meter per second. And that is never going to change, right? So because of that, guys, you can find out the absolute refractive index of that particular medium, whatever the medium is, air, water, glass, whatever medium you take. N medium, which is the refractive index of that medium, is equal to speed of light in vacuum divided by the speed of light in that particular medium. Simple. Moving on to the relative refractive index. Now, relative refractive indexes, see guys, not all of us have experienced vacuumness. None of us have been to space, including me. None of us have been to space. None of us have truly experienced this vacuum, that state we have never experienced that vacuumness. So, in majority of the cases, light is entering from one medium to another. For example, in this case, yeah, the pen is still inside this. Yes, let me take it out. So in this case, light is entering from air into water. So those are two different mediums. This is what is called as relative refractive index. When you measure the speed of light in two different mediums, when light is entering from one medium to another, that is what is called as relative refractive index. When light travels from one medium to another, then the refractive index that you get is called as relative refractive index, because it's, in comparison with something else. Now, here's what you have to do. For example, guys, let's say light is entering from air to water, like in this case, air to water. So what I'll do is that I'll take this as the speed of light in air, I'll take it as V1. Speed of light in water, I'll take it as V2. All right, V1 and V2. And, or you can take it as VA, as they've mentioned over here. You can take it like that, VA and VW. It's totally up to you, whatever. It's a terminology. It's up to you guys. Now, I'll take this as NA, that is the refractive index of air, and NW, that is the refractive index of water. So if I want to know what is the refractive index of water with respect to air, you're comparing the refractive index of water with air. If that is what you want to do, then NWA, this W, whichever is the first subscript, you're finding out the refractive index of that with respect to the next one. So here it is water with respect to air. That will be equal to refractive index of water divided by the refractive index of air. Now, what is this refractive index? This is the absolute refractive index we're talking about. That is basically the speed of light in vacuum divided by the speed of light in that medium. So that's why they've taken it as C by VW and C by VA. That is, you're finding out the absolute refractive index of water and absolute refractive index of air. So when you divide that, what you'll get? You'll get as C by VW divided by C by VA. C gets cancelled. It'll become VA divided by VW. If I want to find out the relative refractive index, I should either know the absolute refractive index of those two mediums, or if I know the speed of light in air divided by the ratio of speed of light in air divided by the ratio of divided by the speed of light in water, or in that particular medium, that'll give you your relative refractive index. Now, on the other hand, if I want to find out, let's say I want to find out the refractive index of air with respect to water. All right, I want to find the refractive index of air with respect to water. So how will that look like? So that time I'll write it as NAW, because I'm finding out the refractive index of air with respect to water. That will become NA divided by NW, that is refractive index of air divided by the refractive index of water, which will be equal to speed of light in water divided by the speed of light in air. Why? Because NA is what? C by VA. And what is NW? C by VW. So CC gets cancelled. This will go to the numerator. This will come to the denominator. So VW by VA. Got it? So that is your relative refractive index. So make sure you take the screenshot of this one. Keep it with you guys, because towards the end of your exam, I don't want you guys to run around looking at your textbook to find out the answer. This is a simpler way to take it. So take a screenshot, keep it with you so you can refer to it whenever you want. Now, yes, guys, one more thing is that if, let's say, speed of light in the first medium is greater than speed of light in the second medium, that means that the first medium is a rare medium and the second medium is a dense medium. I just told you, whichever medium the speed of light is more, that will be a rare medium, and whichever the speed of light is less, that would be a dense medium. Now, on the other hand, if you find out, let's say you're finding out the refractive index of the second medium with respect to the first one, that will be N2 by N1. If this ratio is greater than 1, that means that 2 is a denser medium. Again, because obviously only if you have a higher value, you'll get a value which is greater than 1, right? So if N2 is greater than N1, that means that it is a dense medium. On the other hand, if N2 is less than N1, that means that it is going to be a rare medium. Now guys, now apart from that, a few other factors that affects refractive index. One of that is the nature of the medium. Different mediums have different refractive index. Air would have a different refractive index. Diamond has a different refractive index. Water has a different refractive index. So the density, the nature of the material is a very, very important factor that affects the refractive index. The second one is the temperature of the medium, because as you increase the temperature, the density of the medium becomes less, which means that the refractive index also becomes less. So as temperature decreases, the density of the medium will also decrease, which means that the refractive index will also, as the temperature increases, so the density will decrease and the refractive index will also decrease. The color or the wavelength of light also matters, because again guys, red has a different wavelength and violet has a different wavelength. So the wavelength of the color, so red on the other hand would refract less, so it has a less refractive index compared to violet, which has a greater refractive index because it bends even more than red light. So each and every color has its own refractive index, and those are also another factor that affects the refractive index of medium. And finally, the optical density. The more the denser the medium, more is the refractive index of that medium. Right. One more thing that light always likes is called as principle of reversibility. That's a very important and very interesting thing about light. Let's say, guys, light is traveling from medium number 1 and it's going into medium number 2. That's the path of light. Let's say I reverse the path of light. Let's say I reverse the path of light. You know what will happen? Light will follow the exact same path. Whichever path light came from, it will follow the exact same path. There's a saying, right? Don't forget your past. Don't forget where you came from. Light follows that. Light follows that to the core. Whichever way light came from, when you reverse the light, when you reverse the path of light, it will follow the exact same path. It's not going to change its path at all. It's going to follow the exact same path, and this is what is called as principle of reversibility. Now, this gives you another important thing. For example, let's say I want to find out the refractive index of these two mediums. So here, this is mu, which is nothing but refractive index. So refractive index of the second medium with respect to the first one, which is equal to what? The refractive index of the second medium divided by the refractive index of the first medium. That's what it is, which is also equal to sin I by sin r. That is nothing but your Snell's law, your second law of refraction, right? So we can say that what is that? Mu 2 1, that is nothing but refractive index of the second medium with respect to the first one. This means that you're finding out the refractive index of the second medium with respect to the first one. That is what it means. That is what those subscript, that is what they indicate, which is equal to sine of angle of incidence to the sine of angle of refraction. Now that though you already know from second law of refraction, we know that. So that is the same thing, sin I by sin r. Let's say I want to find out the refractive index of the first medium with respect to the second one. All right. So it's a reciprocal of that. So refractive index of the first medium with respect to the second one would be reciprocal of that. That will be nothing but sin r divided by sin I. Simple. All right. Now, let's say I want to find out the ratio of these two. I want to find out the principle of reversibility. So, mu 2 1 into mu 1 2 will be equal to sin I by sin r into sin r by sin I. We just saw that, no? Sin I by sin r, which is O into sin r by sin I. What will happen? Cancel, 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 cancel. What are you left with? 1. So, this is one of the proof that shows that principle of reversibility does exist. And also, this also shows when you were to compare the two refractive index of the medium, you can also say that the refractive index of the first medium. So here, refractive index of 2 with respect to 1 into refractive index of 1 with respect to 2 is equal to 1. So if I take 1 to the other side, what will I get? Refractive index of 2 with respect to 1 is equal to 1 by refractive index of 1 with respect to 2. So again, if you want to compare two refractive indexes, you can actually say that the refractive index of one medium with respect to another one would be the reciprocal of the second one with respect to the first one. All right. I hope you got it, people. So every time you get a refractive index, you get a refractive index related question and you're asked to find out, you're given one refractive index with respect to another one and you're asked to find out the other one, just reciprocate the value. That's it. So it'll be 1 by refractive index of the first one with respect to the second one. That's it. All right. Anyways, guys, moving on, people, moving on. The next thing that you probably would have studied is nothing but a prism. That is refraction through a prism. Now, what is a prism? Let me explain that first. Prism is nothing but a three-dimensional transparent object. It's a three-dimensional transparent object which basically can be of different shape. You have triangular prism, square prism, pentagonal prism, rectangular prism, hexagonal prism, octagonal prism. You have prisms for pretty much all kinds of geometric shape. Now the prism that we are dealing with is only triangular prism. All right, we are dealing with only triangular prism. So in a triangular prism, people, you have two triangular surface and 3 rectangular surface. All right, so 2 triangular surface and 3 rectangular surface. So basically 5 plane surface in total, 2 triangle and 3 rectangular surface is what you have. Let's say a ray of light is coming and falling on this prism. Now what happens is that because light is entering from air into glass, what's going to happen? It is going to undergo refraction. That's obvious, right? It's going to undergo refraction. So what happens? It undergoes refraction, and this here is my refracted ray. Again, it's going to bend towards the normal since it's traveling from a rare medium to a dense medium. Now, as the light leaves, which would be called as the emergent ray, the emergent ray would be bending away from the normal. Why? Because light is now leaving glass and entering into air. So basically it's traveling from a dense medium back into a rare medium. So what happens? The emergent ray is going to bend away from the normal. And if you look very carefully, guys, the emergent ray is not parallel to the incident ray. Unlike a rectangular glass slab where the emergent ray was parallel to the incident ray, that does not happen in the case of a triangular prism. Why is that so? Because in a triangular prism, the surfaces are at a different angle, whereas in a rectangular glass slab, these two surfaces are parallel to each other. Because they are parallel, whatever refraction happens on the first surface gets reversed or negated in the second surface. That's why it becomes parallel, but that does not happen over here. And the most important thing that you have to remember is that the emergent ray will bend towards the base of the prism. It's going to bend towards the base of the prism, like as you see over here. And if you were to extend the incident ray and the emergent ray, you get an angle between them. And that angle between the incident ray and the emergent ray is called as angle of deviation, which is represented by the letter delta. So delta is nothing but what? The angle of deviation. So this is supposed to be the original path of light. But what happened? Because of refraction, it took a completely different path. It took a completely off-track path and came out this way. So if you extend the emergent ray and the incident ray, the angle formed between the incident ray and the incident ray, that is what is called as angle of deviation. Right, guys? Right, guys, there are a few factors that affects angle of deviation as well. Every medium has its own angle of deviation. So there are a few factors that affects it. One is definitely going to be the fact that the material. The one thing is definitely the material. The type of material would definitely affect the angle of deviation as well. But one other important factor that angle of deviation depends on is the angle of incidence. Let me tell you why. See, guys, as you increase the angle of incidence, angle of deviation will keep on decreasing. Can you see this? This is basically an angle of incidence versus deviation graph. So you see this is the curve. So on your y-axis, you have your angle of deviation, and on your x-axis, you have your angle of incidence. And as you increase the angle of incidence, the angle of deviation is going down. It's decreasing. Once at a certain angle of incidence, the angle of deviation will become bare minimum. It'll become bare minimum. After that, once you go beyond that, so once if you keep on increasing your angle of incidence, the angle of deviation keeps on decreasing. But at a certain point, you will get the most or the minimum angle of deviation. And once you go beyond that angle of deviation, once you reach that minimum value, if you keep on increasing your angle of incidence, your angle of deviation again will increase. That is why the curve basically looks like a parabola. It looks basically like a parabola because of the fact that it is decreasing at first, it reaches the minimum value, and then it keeps on increasing once you keep on increasing the angle of incidence. Now, if your angle of incidence is equal to angle of emergence, if your angle of incidence is equal to angle of emergence, you can also remember this very important formula, which is nothing but angle of deviation, which is minimum, is equal to 2i by a, or minus a, where 2i is nothing but the angle of incidence and a is nothing but the angle of prism. So if in case your angle of incidence is equal to angle of emergence, there's one such relationship that you must remember. Apart from that, yes, guys, like I told you, it definitely depends on the material itself. More is the refractive index of that material, more would be the angle of deviation, less would be the angle of the refractive index, less would be the angle of deviation as well. And one more thing that it depends on is the angle of prism. So the angle of prism that is there, that is also a very, very important factor that helps you to decide what is going to be the angle of deviation. Right, guys? So that was pretty much it. That was your first one-shot series. We have a lot of questions to solve through. But yes, guys, let me ask you this one very important question. Do you need more help for your preparation for your board exams? And if the answer is yes to that question, people, let me introduce Vedantu. Vedantu's online session is not only going to help you to improve your scores, but it's also going to give you 100% clarity on all the subjects. And we have become unstoppable when it comes to results. You can look at the JEE mains result over here. With about 29 students scoring 100 percentile in JEE mains, one of the most toughest exams in the world, not just India, one of the toughest exams in the world. 7 people got 100 percentile in chemistry, 9 in mathematics as well, and 27 students have scored 99.9 plus percentile, with 694 students scoring 99 plus percentile. And yes, guys, if you want to be one of them, if you want to be a topper in your own words, that is basically be a topper for your school or the state or whatever it is, or you don't want to be a topper, you just want to learn and understand the concept, whatever is your ambition, guys, we are here to support you. We are here for you guys. 100% knowledge and guaranteed improvement in your score. If you do not see an improvement in your score, you guys can get your complete fee back without any questions asked, and that is the kind of guarantee that we're giving you. Let me just quickly show you how the sessions are going to be. So guys, this is how the sessions will look like. So once you go to your past sessions, you can see this is how the session would look like. You can check out the replays. Yeah, all of the sessions are live, so you can check through, you can attend those sessions live. If in case you miss out a session or you want to go back to that session, you can always watch the replay of that session whichever part of the world you're in. You can always watch the replay. You guys can download all of the notes that are there in that particular batch. You can even take the quizzes while watching the replay. If you just click on try alternate replay, you guys can even take the quizzes. Yeah, let me just mute it for a second. Yes, so even while watching the replays, if you guys want to take the quizzes, you have an opportunity to do that as well. So lots and lots of options, and more importantly, you have a platform here which understands you, which helps you to be better. 100%, again, like I told you guys, 100% support, 100% conceptual clarity with unlimited doubt solving inside and outside the session. Whatever doubts you have, all of those doubts would be cleared inside the class. Let me just show you how it works. So if I just go to my past sessions right here, if you click on get notes, by the way, people, you can download all of the notes, every single thing, whatever is written on the board, everything can be downloaded. Again, we don't just study, we have a lot of fun as well. So I start off every session of mine with a riddle, have some fun, and then we get into the sessions, because yeah, it's important to have fun as well. You should not hate your you should not hate that learning process. It should be something that you fall in love with. So when you're it's like when you're understanding the concept, we try to make it as fun and as interactive as possible so that you guys can understand and enjoy that class as well. So you can check it over here, guys. 138 doubts were asked in that session, and all of that 138 doubts were cleared inside the session itself. So you get the best of the best and nothing else. So if you just go to this video, this is one of the videos that came out recently. Subscribe to the channel first, hit that red icon, kill it. Now what you're going to do is, guys, click on ICSE Class 10th. So if you click on this link, people, it will directly take you to the website. So this is the website basically, guys. So you can check it over here. I'll just change this to ICSE right here. Class 10th ICSE. So if you just click on it, guys, you can check out all of these courses. Now there are 3 different categories or 3 different choices that you have: Vedantu Light, Vedantu Pro Classic, Vedantu Pro Plus. Vedantu Pro Light has all the basic features. The only thing that is missing here is that you will not have a personal mentor, and you cannot get your doubts solved in the Vedantu app. In Vedantu Classic, that is also removed, where you can actually get your doubts solved even outside the session. In Vedantu Pro Plus, you will also have someone called as a personal mentor who will be with you throughout the entire year to help you clear every doubt of yours, take one-to-one sessions, and be there all the way until your examinations. Just think about it, guys. The whole course, that is until your exams are done, is going to be just 18,000 rupees. Now, if you feel like that's a lot of money, you can also try the 1 month program. If you just click on 1 month program, the price drops on 2,340 rupees. Try it for yourself, and then if you want, you guys can extend your package later, or if you want to get another month of trial, you can do that as well. Or you can also have the EMI option, 1,500 rupees a month until the end of the exam. Again, guys, you'll be getting the best of the best teachers to make sure that you guys are performing exceptionally well in your examinations. right guys? So all of that is up to you. Again, we are just a mere, what to say, messenger. That's all I would say. That's the whole point is this, guys. You have different ways to prepare for your board exams. This is not the only one, but this is one of the best ways to prepare, where you also get an opportunity to study and to practice the kind of questions that you want, and at the same time also enjoy the process of studying as well, right guys? So there's a new set of batch that is starting from 4th of October. So you guys have a very short period of time for both 9th as well as 10th. So you guys want to check it out, the link is right there, right guys? So let's do a couple of quiz questions, check if our level of understanding is what we are or where we are supposed to be, or if there is anything else that we need to correct it. Let's try to do that as well. So here's the first one. The phenomenon of return of light. The phenomenon of return of light in the same medium after striking a surface is called as what? Reflection, refraction, diffraction, or polarization. Quite an easy question, guys. That's like bacha level question. Probably a 6th standard question, 7th standard question. Trust me, you guys are an ICSE. You probably would have studied this in your LKG, UKG. So go ahead. I know, exaggeration. Yes, but still, the answer to this question, guys, is quite simple. It's reflection. The bouncing back of ray of light into the same medium is what is known as reflection. Second question. When a light passes from one rare medium to a dense medium, then the velocity of light increases, decreases, no change whatsoever, or none of these happen. Quite another easy question, guys. You are an ICSE. I'm going to keep repeating that for every question because you guys are an ICSE. You have to remind yourself of that, right? Here's the question. When a light ray passes from one rare medium to a dense medium, from a rare medium to a dense medium, it is definitely going to decrease, guys. Because, again, the density of the medium is more, the speed of light in that medium is less. Next one. The intensity of the refracted rays, refracted light, is always dashed than the intensity of the incident. The intensity of the refracted light is always dashed than the intensity of the incident light. That's more like a tongue twister. Intensity and incident. Okay, intensity, incident. Okay, I can't do it. All right, here we go. Greater remains the same, less, or none of the above. The intensity of the refracted light is always dashed than the intensity of the incident light. The answer in 5, 4, 3, 2, 1. You know the answer, guys, is always going to be less, because there is no, let me repeat this, guys. There's no medium in the world that is 100% reflective or 100% refractive in nature. To give you an example, if you've ever been to a shopping mall, guys, you've probably seen there are some mannequins and stuff, right? You know, for example, let's say you go to a Levi showroom or a Van Heusen showroom, you see mannequins and you can see through that. But have you ever wondered, like when you're looking at that mannequin, if you look very carefully, you will be also able to see your own reflection. Why are you able to see that? It's a glass. It is not supposed to reflect. It's not a mirror, because part of the light always gets reflected and part of the light gets refracted. So the intensity of light is going to be a little less. All right, one more question. The angle between the two plane refracting surface of a prism. If I talk about a triangular prism, the angle between the two plane refracting surface is called as what? Angle of incidence, angle of prism, angle of deviation. All right. Double the marker. All right. Okay. All right. The answer to this question, guys, in 5, 4, 3, 2, 1. It can be either B or C because it's the same thing. It can be either B or C because the answer is angle of prism, but it can be apparently C is the right answer. Anyways, it's both B and C, guys. All right, one more question, last question, and then I have a homework question for you people. An object placed in one medium when seen from another medium appears shifted. The factor on which the magnitude of this shift depends on what? What does it depend on? Does it depend on the refractive index? Does it depend on the thickness of the denser medium, the wavelength of incident light, or all of the above? An object placed in, that is basically, in simple words, what does refraction depend on? I'll answer the question in 5, 4, 3, 2, 1. It's all of the above, guys. It depends on the refractive index. It does depend on the thickness of the material. It also depends on the wavelength of light as well. And this here is your homework question. Do make sure you check out and do solve the question and let me know in the comment section how this question went. The question is this, guys. The ratio of angle of incidence to the sine of angle of refraction equals to refractive index is called as what? All right. Equals refractive index is called as what? Let me know in the chat box and as well as in the comment section, right? So that's all people for today. Thank you for joining. I hope you enjoyed it. I hope it was helpful in one way or another. I'll catch you guys in the next one shot series, which will be coming out pretty soon. All the best for your exams, guys. Take care of yourselves, stay safe, and chill out. Just chill, bro, chill, and enjoy your life. All right. See you soon. Take care. Bye bye.